This is your homework 11-3. It is the green homework paper. Do not attempt this green homework paper unless you have your yellow notes, ISN 11-2, rational functions, on your desk. Stop this video right now and get ISN 11-2 notes out on your desk. They are bright yellow. When you are graphing, the first thing you need to do is factor your equation. When I factor this equation, there isn't anything that canceled out. So over there on the right-hand side, underneath the word whole, you write none, because there is not anything that canceled out. Now, you pick up your yellow notes and you look at your yellow notes, and it says under number 2, vertical asymptote, set the denominator equal to 0 for a vertical asymptote, and solve. That is your vertical asymptote. Now, we arranged this problem differently than your other paper so that the things that would be together are grouped together. So the domain is all real numbers except the asymptote. Then you go to the box at the bottom. The next thing it asks for is the horizontal asymptote. So you turn in your yellow notes and you look at horizontal asymptote, and it talks about degrees. Another name for degrees is the exponent. In the original problem, you have a 9x in the numerator, and that's to the first power. Now, it's not the 9 we're looking at, it's just the x to the first power. In the denominator, you have a 3x. And of course, it doesn't have a power, so that would be 3x, but it's not the 3 we're looking at. Excuse me. It is the powers. Those, of course, would be equal. So you look at your notes, that would be 3b. When they're equal, the asymptote is y equals a over b. What's it talking about, this a over b? That would be the 9x over the 3x. You don't care about any of the rest of the equation. Just the part that has the highest degree. Those cancel out. And 9 over 3 reduces to 3. That would be where your asymptote is. And your range is all real numbers except y equals to 3. Pick up your yellow notes. Look at what it says for an x-intercept. It says set the numerator equal to 0. It doesn't matter whether it's the factored numerator or the unfactored numerator, you will get the same answer. Subtract 18 from both sides. On your yellow notes, it says that for the y-intercept, you solve f of 0. What does that mean? Write down the original equation or the factored equation. It doesn't matter which one. In place of the x, put a 0. So this would be 18 divided by 0. What is 18 divided by 0? You cannot divide by 0. So that would be not possible. There is not a y-intercept. Then you take all of this stuff that you just figured out and you put it on the graph. So the graph says that I have a vertical asymptote at x equals 0. Vertical is going up and down this way. Please use a red pencil for your asymptotes so that I can see them. It doesn't have a hole. It has a horizontal asymptote at 3. I have an x-intercept at -2. And I don't have a y-intercept because I have an asymptote there. Now, if you want to be an overachiever, you can calculate some more points on the graph, but this is basically what this side of the graph is going to look like. It's going to have that, if it has these 2 asymptotes, it's going to have those 2 branches like we did on the pink worksheet at the first of this unit. To figure out the top part over here, it's going to be symmetric to the bottom part. So this point right here is over 2 and down 3. So its matching point will be over 2 and up 3. I'm going to have a matching point up there, and it's going to curve toward the asymptotes. This is just a sketch. It's not meant to be exactly perfect. On problem number 2, the first thing you do is to factor. And then we notice on problem number 2, this part right here cancels out. When you have a part that cancels out, that is what is going to give you the whole. The x plus 2 equals 0 is going to make a whole. Subtract 2 from both sides, the whole is going to be at -2. A hole is a missing point on the graph. If the point is missing, then it's going to have an x value, and it's also going to have a y value. So I also have to figure out the y value. I need the reduced function from the previous part, the previous box. This is what I had left after I reduced. That's what I need to use to find the y part of the whole. I am going to substitute in that 2 that I just found. So that is going to be 3 over -4 from our function notation. That makes a point, that's going to make a hole in the graph right there at that point. On your yellow notes, it says to find the vertical asymptote, the denominator needs to equal 0. The denominator after you canceled out the whole. By the way, if you canceled it out and it didn't have a denominator anymore, it would not have a vertical asymptote. And so add 2 to both sides, and so that's where the vertical asymptote is. Now, we, again, rearrange this paper so that the things that go together are here in the same box. So the domain is all real numbers except the asymptote and the whole. To find the horizontal asymptote, you have to compare the degrees. We have a 3x, and on the bottom we have an x squared. If you have more than one x, you compare the more than one x in the numerator or more than one x in the denominator, you compare the biggest one. It's not the 3 that we're comparing, it's the x's. And it's not even the x's, it's the degree on the x's. So that x to the first power is less than x to the second power. You look on your notes, that would be on 3a, and it tells you that the asymptote is going to be at 0. The range is going to be all real numbers except the asymptote. Where'd that come from? That was the y part of the whole. The x-intercept is the numerator equal to 0. That's not possible, so there is not an x-intercept. The y-intercept you substitute a 0 in for the x. It doesn't matter whether you use the reduced one or the original one, you're going to get the same answer. Now, it's going to be probably easier to figure out where it goes on the graph if we put it in a decimal form. And so that's the decimal form. Put this take all of this stuff, put it on the graph. It's going to have a horizontal asymptote, vertical asymptote at 2. It's going to have a horizontal asymptote at, I think I've got my verticals and horizontals mixed up. But vertical asymptote at 2, horizontal asymptote at 0. It's going to have a hole at -2, -3/4. It's going to have a y-intercept at -1.5. So it's going to look something like this. When you have the two asymptotes, you will usually have the two branches, and they will be symmetric. 1, 2, and 1.5. 1, 2, 3, 4. 1, 2, 3, 4, and 3/4. But on this side, it will not be a hole in the graph. There's only one hole in the graph. You will take a quiz on this. You may use your green paper on the quiz. You will staple your green homework to the back of the quiz. You may use your green notes on the quiz.